All right, let's talk about trigonometry. Now, if that word alone gives you a headache and flashbacks to memorizing endless formulas, you are definitely not alone. But what if there was a master key? A single, simple idea that makes all of it just click? Well, stick around because we are about to crack that code.
So tell me if this sounds familiar. You open up your textbook, you're looking at trigonometry, and it just feels like this giant, overwhelming list of rules and weird formulas. You've got sine, cosine, tangent, and all these special identities you're supposed to have locked in your brain for the exam.
And you do it. You spend hours cramming, you make the flashcards, you write them out 100 times. But then you get into the exam, you look at a problem, and your mind just goes blank. You have absolutely no idea which of those 50 rules you're supposed to use. It is so frustrating.
But here's the thought. What if we've been looking at this whole thing completely backward? What if the real secret to finally getting trigonometry doesn't have anything to do with triangles and sides, but instead it comes from the simple, perfect shape of a circle? I'm telling you, this one shift in how you see it changes absolutely everything.
So, our journey has to start with the most basic thing of all, the angle itself. Seriously. Because before we can get into sine and cosine, we have to talk about the best way to actually measure a turn. And, well, the way you probably learned in school, it might not be it.
Look, we all know degrees, right? 360 in a circle. But if you stop and think about it, why 360? It's totally arbitrary. Someone, way back when, just decided to slice a quarter of a circle into 90 pieces and called them degrees. Radians, though, they're different. They weren't just made up, they come directly from the nature of the circle itself. They're a pure real number.
And here's what that actually means. A radian is just how far you've walked along the edge of the circle, but you're measuring that distance in radiuses. So if you walk a distance equal to 1 radius, boom, you've turned 1 radian. And since it's a length divided by a length, the units just cancel out. You're left with a pure number, and that's the whole magic of it.
Okay, the formula's fine, but let's get a feel for this. What does a radian actually look like? If I told you to turn your head by 1 radian, how far would you turn?
Well, 1 radian is about 57 degrees. You can see it right there. It's a pretty decent-sized angle right in that first quadrant. It's not some weird concept. It's just the number 1.
Now watch how this works. If we go 2 radians, we just travel twice that distance along the edge, and that lands us right in the second quadrant at about 115 degrees. Again, it's not some weird trig symbol, it's just the number 2.
And check this out. If we go 3 radians, look at how close we get to a perfectly straight line. We're at about 172 degrees, just a little bit shy of 180. You know why? Because a perfect 180 degrees is pi radians, and pi is about 3.14. See? All of a sudden, radians aren't weird at all. They're just numbers telling us how far we've walked around a circle.
All right, you ready? This is the main event. What I'm about to show you is the single most important, most powerful idea in all of trigonometry. Once you really get this, that whole house of cards built on memorized formulas just completely falls apart.
Okay, I want you to forget everything you learned about opposite over hypotenuse, just for a second. The real definition is this. Picture a circle with a radius of 1. We call it the unit circle. Now pick literally any angle, let's call it theta. Go to that angle on the circle. The spot where you land has an x-coordinate and a y-coordinate, right? Well, that's it. The x-coordinate is the cosine of that angle, and the y-coordinate is the sine. That's the entire definition, full stop.
And this one simple idea instantly explains so many of those rules you had to memorize. Like, why are sine and cosine always stuck between -1 and 1? Well, because you're on a circle with a radius of 1. The x and y values can't possibly go any further than that. Why do the signs change in different quadrants? Because the x and y coordinates become negative over there. It explains all of it.
Let's put this new superpower to the test right now. No triangles, no calculator, just using our new circle definition. What is the cosine of 180 degrees?
It's simple, right? You just go 180 degrees around the circle. Where do you land? On the far left side. And what are the coordinates of that point? They're -1, 0. Since cosine is just the x-coordinate, the cosine of 180 is -1. No memorizing needed, you just see it.
Okay, let's do another one quick. What is the sine of 270 degrees? Just think, where is that on the circle and what would its y-coordinate be? Exactly. 270 degrees is straight down at the bottom of the circle. The coordinate of that point is 0, -1. And since sine is just the y-coordinate, the answer is -1. It's really that easy.
Okay, so now that we have this master key, let's use it to unlock one of the parts of trig that always feels super confusing. All those rules for related angles, sometimes called allied angles.
So let's compare an angle, theta, with the angle pi minus theta. That's 180 degrees minus theta. If you look at them on the circle, you can see they're perfect mirror images of each other across the vertical y-axis. So what does that tell you about their coordinates? Well, they have the exact same height, the same y-coordinate, but their x-coordinates are opposites. One's positive, one's negative.
And right there, you see how these rules just become obvious facts. That formula, the sine of pi minus theta equals the sine of theta, that's not a rule you have to memorize anymore. It's just you looking at the circle and saying, oh yeah, those 2 points are at the same height. Same for cosine. The cosine of pi minus theta equals negative cosine of theta is just you saying, yep, 1 point is on the left, 1 is on the right. You are no longer memorizing, you are seeing.
So let's bring this all home. We've basically thrown out a giant mountain of confusing formulas and replaced it with one simple, powerful visual way of thinking. This is the new way to approach trigonometry.
From this moment on, whenever you see a trig problem, I want you to follow these 3 simple steps. First, picture the angle on the unit circle. Second, find the exact point where that angle lands. And third, just read the coordinates. That's your answer. Cosine is the x, sine is the y.
You see, in the end, trigonometry was never really supposed to be about memorizing a bunch of weird rules about triangles. It's about the beautiful, predictable, and elegant journey of a single point traveling around a circle. And once you truly see it that way, you realize you can make this subject ridiculously easy.